Welcome to Friendly Math 101. Today's lesson is over, Algebraic Proofs. I'm calling this an introduction because I'm not going to go into too much detail, but hopefully the examples that I'm going to show you today will help you understand how to write a proof. So we will do two examples. The first one and the second one, we're just going to solve it normally. Then we're going to write the formal proof. So this first example says, prove if 3x minus 11 equals x minus 1, then x equals 5. So we're given a problem, 3x minus 11 equals x minus 1. Let's solve for x and see what we get. So the first step to do this is to just move all the x's to one side. So I'm going to subtract x from both sides. What that does is gets rid of it from the right hand side and puts it on the left hand side. 3x minus x is 2x. Bring down your minus 11. Bring down your equal sign, and then negative 1 is left on the right. Now this is just a two-step equation. So I just want to undo what's not attached to x first, which is this minus 11. To undo a subtraction of 11, I'm going to add 11 to both sides. That will zero that out on the left-hand side. I'm left with 2x equals negative 1 plus 11, which is 10. Then I want to get x by itself, so I'm going to divide both sides by 2. That one's out there, and I get my answer, x equals 5. So I actually just proved that x equals 5 if 3x minus 11 equals x minus 1. I've done my job. Now let's go to the final proof. In the final proof, we're going to put in the statement section every step that we took. So I actually had already written them out for you. Then on the right-hand side, in that column, we're going to write the reasons why we're able to do this, or what did we do to get to this step. So the first statement is 3x minus 11 equals x minus 1. Well, I didn't come up with that out of thin air. That was just given to me. So the reason is that is given. Then we got down to this next step. How we got there was subtracting x from both sides. That's the first thing we did. We're able to do that by subtraction. So the reason is the subtraction property allowed me to do this. To get to the next step, what we did was add 11. So the reason for that would be the addition property. All we're doing in the reasons is explaining how we got to that step. So the first one was given to us. The second one we subtracted. The third one we added. To get to our final answer, x equals 5, we divided. So this is the division property. And that is our algebraic proof. Moving on to our next example. This example says, prove if x equals 15, then A is parallel to B. Well, we know A is parallel to B if one of those 5 theorems are true. We have same side interior angles are congruent, same side interior angles are supplementary, alternate interior angles are congruent, we have corresponding angles are congruent, alternate exterior angles are congruent, same side exterior angles are supplementary. So we really need to look at what kind of angles we have here. We have here alternate interior angles. These should be congruent. So these should be equal. That will only happen if A and B are parallel. That's how we prove this is true. If these are equal, then we can prove that they're parallel. So we're given this x equals 15. We need to plug that in here. And if those two sides are equal, then we have parallel lines. So I'm just going to plug 15 into my x. I'm trying to get that to equal 39. 3 times 15 is 45. 45 minus 6 is 39. 39 equals 39. Check. So these are equal, meaning A and B are parallel. So we just proved it. Now let's write our formal proof. So just like in the last example, I already have the statements written out. The first one is x equals 15. That was given to us in the problem. The second one is the measure of angle 1 is 39. That was also given to us. It was already labeled on the picture. The third one is the measure of angle 2 equals 3x minus 6, also given to us in the picture. So the next step that we took was we plugged in the 15 for x for angle 2. That is called substitution. So all we used there was the substitution property. We substituted x into the equation and we got 39. Now that we know angle 2 is 39 and angle 1 is 39, we can say angle 1 and angle 2 are equal. That is also the substitution property. Because if angle 1 is 39 and angle 2 is 39, where it says 39, I can put angle 2 in there and they are equal. That's substitution. So now that we have angle 1 and angle 2 are equal, then I can say angle 1 and angle 2 are alternate interior angles. This is by the definition of alternate interior angles. They are on the same side of on opposite sides of the transversal. They're the insides of the two lines, so they are alternate interior angles and they're equal. Therefore, this is what we were trying to prove. A is parallel to B. And that would be the formal proof for the second example there. Thank you for watching, and for more math tutorials, please subscribe to our channel, Friendly Math 101.